The 1950s. On the world's highways, machines appear that look like props from a mad scientist's laboratory. This was the dawn of a new age, and engineers, free from the constraints of war, unleashed their wildest ideas onto steel and chrome. The results were shocking. Cabins shaped like rocket cockpits, forms that seemed to defy gravity, designs that were unapologetically strange. These were not just trucks, they were statements. But what if this visual chaos was not an error? What if behind every bizarre curve there was a genius calculation, a logic we have forgotten how to see? This is an investigation into the most radical trucks ever built. We will analyze the evidence, from a creature that looked like it escaped onto the highway to machines built for a world that never came. To find the answers, our investigation starts with the smallest, most overlooked hero of this story, a machine that looked like an insect. Our investigation begins with a machine that proves genius is often hidden in plain sight. While others built giants, British engineers at Scammell created something entirely different for the chaos of post-war ports. The late 1940s. Britain's ports and railway yards are a labyrinth of steel and cargo, a chaotic landscape where every inch of space is contested. The solution was not more power, but more agility. The Scammell Scarab, a mechanical insect, its cabin hanging over the front axle, made the truck look like a creature crawling among giant freight containers. For the driver, this was a visceral experience. The seat was positioned almost directly on top of the front axle, transmitting every bump and vibration straight up the spine. They called it an industrial go-kart, a raw, unfiltered connection to the machine. The Scarab approaches a massive, motionless trailer. Its small, four-cylinder engine, just 90 horsepower, roars at its limit, the sound of a machine working on the edge of its capability. The driver cranks the wheel. The entire cab seems to pivot on a single point, followed by the screech of rubber on concrete. The trailer follows obediently, navigating a narrow gap between rail cars where a conventional truck would be hopelessly stuck. This wasn't a highway vehicle. It was a specialist, built for one purpose. The 4-speed manual transmission was geared for pure torque at low speeds, designed to haul impossible weights in impossible spaces. One driver, one tiny truck, an entire logistics network kept in motion, just 90 horsepower to single-handedly move multi-ton freight loads. But what if a truck wasn't built for work, but for a show? While one machine was engineered for labor, the next in our investigation carried no cargo at all. Its purpose was to transport something far more abstract, the future. This was the GMC Future Liner. It moved across the American landscape like a land-based ocean liner, so tall the driver commanded the road from a central cockpit perched at the height of a second-story window. Its form was a contradiction, a massive, streamlined vehicle that hauled nothing. Its 145 horsepower engine wasn't designed for heavy loads, but simply to propel this mobile theater from one town to the next as part of General Motors' Parade of Progress. The real show began when it stopped. On a quiet town square, its vast, gleaming side panels would rise with a pneumatic hiss. Light would spill from within, revealing a complete theatrical stage. The dazzling red and white body and polished chrome acted like a mirror, reflecting the astonished faces of the crowd. This was not a truck. It was a spectacle. Inside, Americans saw the promise of tomorrow, early robotics, new energy sources, and visions of a world transformed by technology. This machine was a rolling vessel of ideas, an instrument of influence. Today, it's not just an exhibit. One Future Liner sold at auction for over $4 million, becoming an artifact of a bygone dream. But while America was dreaming, others were building to survive. But while GMC was showing off the future in cities, in 1957, French engineers at Berliet were building a machine to survive the present, in one of the most brutal places on Earth. And for that, they needed 700 horsepower. The enemy was the Sahara Desert. Not a landscape, but an active, hostile force. 1,000 miles of sand and rock with no roads, swallowing anything less than indestructible. To claim the oil buried beneath it, France needed more than a truck. It needed a monster. The answer was the Berliet T100. Its tires were taller than a man. The driver sat in a cabin perched nearly 10 feet in the air, piloting a machine that weighed over 50 tons, empty. To move this mass across shifting dunes required a heart of immense power. A 28-liter V12 engine built not for speed, but for relentless, unstoppable torque. Its purpose was simple: haul entire sections of pipeline and drilling rigs where no roads would ever exist. This giant was not just an engineering marvel, it was a tool for colossal industrial projects, hinting that behind these machines were not just inventors, but entire economic and geopolitical systems. Systems that demanded even more powerful and deadly machines. The Berliet T100 proved that trucks could serve massive industrial goals, but other, equally powerful forces dictated their own terms to engineers. What if the main enemy wasn't desert sand, but nature itself in its most merciless form? For the answer, we travel to post-war Czechoslovakia. The machine is the Tatra 111. Its heart was an air-cooled diesel V12, a 14.5-liter behemoth with a displacement equal to nearly 8 modern passenger cars combined. In the deep freeze of a Siberian winter, it didn't roar. It produced a low, guttural growl that refused to surrender to the cold. The sound of mechanical survival. But how did this truck conquer a frozen wasteland where steel becomes brittle and roads cease to exist? The answer wasn't power, it was geometry. Instead of a standard ladder frame, Tatra engineers built the 111 around a single rigid backbone tube. From this spine, independently suspended, swinging half axles reached out to each wheel. The process is brilliantly simple. A front wheel encounters a frozen boulder and pivots sharply upwards. But the central tube, the truck's entire frame, remains almost perfectly horizontal. The other wheels stay planted firmly on the treacherous ground, clawing for grip, maximum contact, constant traction. The truck simply walks over obstacles. A conventional leaf spring truck would be thrown violently, its frame twisting and its wheels losing contact with the ice. It would be useless. This unique design was the only reason the Tatra 111 could operate for decades in the punishing construction projects of Siberia. It wasn't a feature, it was a passport for survival. And this indestructible DNA had its origins on the battlefield, as the truck was first designed during World War II for the German Wehrmacht. The indestructible Tatra 111 was built to conquer nature, but at the same time, the world was entering an era where the main challenge was no longer the climate, but man. The Cold War began, and it demanded proven weapons be brought out of the arsenals, even if those weapons were on wheels and originated in the 1940s. This was the Diamond T980, a rolling relic from a global conflict. Its design wasn't a product of post-war optimism. It was a hardened veteran first developed for the battlefields of World War II. Under its long hood was a massive 14-liter Hercules engine, but it produced what seemed like a modest 185 horsepower. Not enough. Or was it? The secret of the Diamond T was not in speed, but in sheer relentless force. That power was converted into colossal torque, fed through a complex transmission system that gave the driver an arsenal of gears. Its only purpose was to pull immovable objects. Its main task was to haul battle tanks, machines weighing dozens of tons, from mud, across rivers, and over broken terrain. When the war ended, the Diamond T didn't retire. It re-enlisted. As the Iron Curtain fell, these same trucks became the backbone of NATO's early logistics, a proven asset in a world of new threats. While America relied on its trusted workhorse, British engineers began sketching a new kind of giant. The American Diamond T was a reliable veteran, but the arms race demanded new solutions. While the US relied on the legacy of the 40s, the British created a machine specifically for the new era, a monster with 250 horsepower whose task was not just to tow tanks, but to become their personal locomotive. This is the Thorncroft Antar. Its mission: transport the new 50-ton Centurion tanks where no railway existed. The driver engages the lowest gear. A deep vibration shudders through the cab, a low-frequency hum from the engine straining at its limit. The wheels grip, almost slipping, as the machine begins an impossibly slow crawl. It's not driving, it's a geological shift. The combined weight of the truck, trailer, and tank created a land train, a moving mass of steel equivalent to 30 passenger cars. This wasn't just logistics, it was a new doctrine. For every new division of heavy armor, a shadow division of these giants was required to move them. Total weight under a single driver's control: nearly 100 tons. While engineers on both sides of the Iron Curtain were creating machines to move tons of military steel, a different war was brewing in America, an economic one, and its weapon looked completely different. It had over 300 horsepower and was created not for battlefields but for the asphalt rivers of new highways. This was the Fageol Super Freighter, a machine born in the early 1950s from the logic of pure commerce. Its futuristic forward cab design placed the driver directly over the engine. This wasn't a stylistic choice, it was a calculated engineering move. By shortening the tractor, Fageol gave operators the ability to pull longer trailers, maximizing every inch of legally allowed cargo space. For the owner-operator, this meant survival: more cargo per trip, more revenue. The driver sat high above the road, commanding a machine built for one purpose: to conquer distance. One operator in the American West drove his super freighter for over a decade. He crossed deserts and mountains, accumulating hundreds of thousands of miles. The engine just kept running. These trucks became the lifeblood of a booming nation, symbols of an economy moving at highway speed. They were not built to navigate bomb craters or ford rivers. The view from the cabin was simple. The road ahead was empty and endless. Post-war America demanded not just power to rebuild the country, but flexibility to serve its growing cities. But how do you deliver goods to every home when the streets are getting tighter? International Harvester's engineers found the answer not in force, but in form. They created a machine that looked more like a metal capsule on wheels than a truck. The International Harvester Metro Van, a friendly alien on the streets of the 1950s. Its design was a stark departure from the aggressive, angular trucks of the era, appearing more like a rolling milk can than a commercial vehicle. Underneath the curved steel was a simple, reliable powertrain, a 120 horsepower engine and a durable manual transmission designed for the constant rhythm of urban delivery. Stop, go, all day long. Its true purpose was not defined by the engine, but by the sounds it made. On quiet suburban mornings, it wasn't the motor you heard, but the gentle clinking of glass milk bottles in the back. It left the factory floor, a shell of gray, anonymous steel. But then, a painter's hand traced a cheerful logo across its curved side. Suddenly, a familiar jingle echoed down the block, and a crowd of children flooded the street, running toward their hero of the summer. This was its genius. It was a tool that became a memory, a cargo hauler that became a cultural icon. While it served dutifully as a mobile workshop or a delivery vehicle, its most beloved form was the one that brought joy, a workhorse in disguise. The small van completes its route, its gentle jingle fading down the street. Far away, on a massive assembly line, a different kind of machine begins to take shape. From the friendly capsule that won the hearts of city dwellers, we shift to a machine born of cold calculation. Authorities had limited the total length of commercial trucks, a move that threatened the entire logistics industry. So engineers at REO made a daring choice. They didn't shrink the cargo, they erased the hood. They put the driver on top of a 220 horsepower engine. This was the birth of the cabover engine design, a brutal but brilliant solution to a legal problem. The process was simple. By eliminating the long nose of a conventional truck, the vehicle could haul a longer trailer without violating the overall length restrictions. It was a victory of geometry over regulation. But what did this mean for the driver? The sensation was alien. The floorboards pulsed with the power of an inline-six engine just inches below. The view was a sheer drop to the road, but this strange, elevated perch offered an unparalleled advantage in tight urban spaces. The question was never about comfort, it was about efficiency. So how do you perform maintenance on an engine buried beneath the cabin? The entire structure had to pivot forward, a delicate balancing act for over 1,000 pounds of steel. If the REO cabover was a brilliant engineer lawyer, the next giant was an artist and an athlete. Forget compromises and limitations. The Kenworth Bullnose, with its 300 horsepower heart, didn't bend the rules. It roared down the highway as if it were creating its own. Its identity came from one unmistakable feature. The camera closes in on a massive, perfectly curved chrome grille, polished to a mirror shine. This shape is a direct visual echo of an enraged bull, its head lowered for an attack. The silhouette of the animal overlays the truck's front end, a perfect fusion of biology and mechanics, an icon forged in steel. They called it the Bullnose, but this was not just aesthetic bravado. Beneath that sculptural hood was pure, unrestrained force. The engine was a colossal heart with a displacement of over 10 liters, generating more than 300 horsepower. That's enough pulling power to rival a small locomotive, capable of dragging entire fortunes and cargo across the continent. When this machine passed, you didn't just see it, you felt it. A deep vibration traveled through the asphalt, a low-frequency tremor that announced its absolute dominance. This was the truck's core contrast, the face of a rolling sculpture, the heart of a heavyweight fighter. It was the ultimate statement on the open road, a symbol that practicality could also be beautiful, and that power could be a work of art. Its reign, however, was brutally short. The legendary Bullnose design was produced for only 5 years. From the Bullnose to the cabover, these machines feel like bizarre artifacts today. But behind the chrome and steel is a story of how engineers answered the call of their time. The 1950s weren't just an era of optimism, they were a pressure cooker of logistical challenges. A nation was expanding, and the old ways of moving goods were not enough. These trucks were the answer. They weren't design mistakes or stylistic quirks. They were surgical solutions to problems of length, weight, and power. Each strange curve, each unconventional cabin was a deliberate act of engineering creativity born from necessity. These machines are the physical evidence of an entire industry refusing to accept limitations. They are monuments cast in iron to a time when every limit was an invitation to build the impossible. If you found value in this story, a like and subscribe helps us create more. We explore the machines that built our world. Thank you for watching.